Hey boys and girls, in case you were absent our first day back to school in January, we started division today. So I'm going to do a brief overview of the lesson we did in class so that you can feel confident about moving on to the next lesson with us in class. Okay, so this is division that we started, dividing by one-digit numbers. This is in volume 1. We started out on page 132 where we did the Are You Ready? In this lesson, or this page, was to remind us of the stuff that we already know from last year. So let's take a closer look at this. We talked about division being related to subtraction. All right, what does that mean? Well, you know that multiplication can be represented with repeated addition. Well, division is the inverse of multiplication, and it can be represented with repeated subtraction. So in this first question, we use a number line to show 93 divided by 3. Well, it means we have 9 in the group, so we start at 9. We're going to count off groups of 3. So we subtract, or we back count. We skip down to 9 minus 3, which is 6. And then we skip count down again to 6 minus 3 more is 3. And then 3 minus 3 more is 0. So I'm going to subtract 3 times there. So that means that 9 divided by 3 equals 3. So the number of times that I had to take away 3 tells me the number of times 3 will go into 9. Okay, with division, it can also mean we are working with equal groups. Now you're familiar with equal groups because of multiplication. Right over here we have a picture of an array. We know that these 4 rows right here represents 4 times 6. So I know there are 24 flowers in that array. How does that represent division? Well, let's take a look at this. Manuel has 24 flowers. Here's the 24 flowers. He wants to fill 4 vases, each with the same number of flowers. How many flowers will be in each vase? Well, I know the total number is 24. And I want to share that out into 4 vases. Well, I see here I have 4 equal groups. So each row can represent one of the vases. So I know there are going to be 4 groups of flowers, group 1, 2, 3, 4. And in each group, there's going to be 1, 2, 3, 4, 5, 6. 6 flowers in each group. So I know that if I have 24 flowers and I'm going to divide that or share it out over 4 vases, the number in each group is going to be 6. So he's going to put 6 flowers in each vase. All right, so here you have 2 problems that the class had to complete on their own, and that is using an array to solve these division problems. All right, in this problem we have 18 tiles. Now we laid out 18 tiles in class, just like this, and we had to divide them into 3 equal rows. And so that looked like 3 rows. And I'm going to put 18 tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so I have created an array that is 3 by 1, 2, 3, 4, 5, 6, 6. A 3 by 6 array. So that means if I take 18 tiles, which I have, and I divide it up into 3 equal rows, this is our row 1, row 2, row 3. Divided into 3 rows. How many is in each row? Well, I can count and see that there are 6 in each row. So 18 divided by 3 is equal to 6. In this problem, I have 20 tiles. I want to put 5 in each row. How many rows will I have? Well, in this problem, I know how many to put in each row. I'm going to put 5 in each row. 1, 2, 3, 4, 5. So in my first row, I have 5. So my second row, I have 5 more. That's 10, 5 more, 15, 5 more is 20. The question is, how many rows do I have? Well, I have 1 row, 2 rows, 3 rows, 4 rows. I have 4 rows of tiles. So that tells me if I have 20 tiles and I put 5 in each row, I divide it out into 5, I'm going to have 4 rows of tiles. Now in the lesson itself, we were using models and equations to represent division problems. Now the two key words there are models and equations. Now a model is something that you use to represent a problem. It can be using manipulatives, or you might use a picture. All right, here I've drawn a picture of a model that's an array form. And here I've taken the same model but put it into sets. All right, I can see that I have 2 rows with 5 in each row, so I know there are 10 objects in that array. And here I have 2 sets with 5 in each one. All right, there are 10 objects in that set. Or I can write equations. 2 times 5 is 10. This is 2 groups of 5 is equal to 10. Or I could write a division problem for that. A total of 10 divided into 2 equal parts. There's 5 in each part, or 5 in each group. So these are models and equations used to represent division. In the first problem, we have a word problem that involves using these tiles over here, these alphabet tiles. Jean and Stephanie are playing a word game with these letter tiles. To start, they place all the tiles in 2 equal rows. I know there are 26 tiles here, and I have to place them in 2 equal rows. Well, let me model that with a manipulative. So right here I have 26 tiles, and they don't all fit under this document camera, but you can see that I've got an array, 2 equal rows. It's an even number, so it's going to divide by 2 equally, and I can see it's two rows, and if I count the length of them, there are 13 tiles. So that tells me that if I have 26 tiles and I split them up into 2 rows, that I'm going to have 13 of the tiles in each row. Another way to model that will be using my base 10 blocks. I'm starting out with 26, and I want to organize that into 2 rows, 2 equal groups. Well, that's easy enough because I could put 10 and then 3 more in each row. And so I've created an array using my base 10 blocks. So I've got row 1, row 2, and then 10 plus 3 is 13, 13 in each row. So in the first problem, we are going to make a model to answer the question of how many tiles are in each row. Well, if I take 26 tiles and split them into 2 rows, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm going to have 13 tiles in each row. 26 divided into 2 rows is going to be 13 tiles in each row. Or I can draw my base 10 blocks using a quick picture. Remember, the long is represented by a line, and the units are represented by little dots. So there is 10 plus 3, that's 13. 10 plus 3, that's 13. And I know 13 is 26, so 26 again divided by 2 is 13. So let's look at the problem on the back. Okay, on this problem, we have 42 water balloons. And for a balloon race, each player needs 3 balloons. How many players are in the race? Now in this problem, we know the total. The total is 43. excuse me, 42. And I have to put them in groups of 3. Well, that's going to be very hard for me to put groups of 3 using the base 10 blocks. So I need a different way to group these. I need this to be broken up into single units. Okay, I'm going to use my tiles. So I'm going to get 43 tiles. And 42 tiles. I don't know why I keep messing that up. And I'm going to start putting them into groups of 3, since I know how many there's going to be. That's going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. So here I've got it. I had 42 balloons. I need to group them, 3 in each pile, and that will tell me how many players I can have playing this game. If I count how many of these little piles I have, or how many groups I have, that will tell me how many players are going to be able to play the race. So my total of 42 is divided up into how many is going to be in each group, which is 3. And when I can't get a 2 is how a 2, 42 divided by 3. And I can count the number of groups I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I see I have 14 piles. So that tells me that 42 divided by 3 is going to equal 14. All right, I'm going to draw that visual model on my paper. I know I start out with 42 of the balloons, and I know I have to put them in little piles of 3, or little groups of 3. The answer that I get is going to tell me how many piles I'm going to have. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 players can each get 3 balloons and play in this game. All right, so how did I represent the number of balloons that Teresa fills? Well, I did that with the 42 tiles that I started out with. How did I represent the number of balloons each player needs? Well, I made a little pile of 3. I put 3 tiles in a pile. How can you use your representation to find the number of players? Well, if I take those 42 tiles and I put them in piles of 3, I can count my number of piles to see how many players can be in the race. 42 divided by the 3 equals my 14. So 14 players can be in the race. Now this is what's called the equation. 42 is a dividend divided by this divisor equals my quotient. Vocab words, dividend, divisor, and the answer, which you already know, that's called the quotient. All right, boys and girls, that's pretty much the basics of what we covered in class today. And I hope that helps you in understanding this lesson. See you at school.